All right, we're talking about ionic and metallic bonding. Ionic bonding. Name two types of ions that you like. A cation, which is
Positive.
and it's positive because what has it done? Lost an electron. And it is going to bond with a anion, which is
Negative.
because it has
Gain.
gained electrons. Okay, maybe we should just be done with this unit because that's the bottom line of pretty much everything we're going to do. Okay, let's talk about electron dot structures. Remember, you only show the valence electrons, and each valence electron is a dot. The number of valence electrons, the last digit in the group number from the periodic table. No more than 2 dots per side, and other than that, I don't give a hoot where you put it. And I think you are well versed in that. Okay. Now, let's talk about the formation of ions. Please write this down. Okay. So atoms will gain or lose just so they look like a noble gas. And the way they look like a noble gas is to have the same electron configuration. They either want an octet. Octet is a fancy word for the number 8. Or they want nothing in their outer shell. If they empty the outer shell, it's their valence electrons, the next lowest shell. Let's work with these. I would like you to write the electron configuration for these 3 atoms right now. leave some space like I did. Okay, so calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. How many valence electrons does it have? Two. Here they are right here. And how did I know they were valence electrons? Because they are in the outermost shell or energy level. How can I tell it's the outermost? It has the biggest number. So it has 2 valence electrons. Is it easier to get to 0 or to get to 8?
0.
Get to 0. So it's going to get rid of these valence electrons, and its new electron configuration would look like this. Those are gone. And when we look at this, calcium started out with 20 protons. And now it has how many electrons? 18 for a total charge of +2. So if we were to write its electron dot, we would write calcium +2. Where are its valence electrons? They're gone. They were given away. So calcium, when it was an atom, looked like this. Now when it's an ion, it looks like this. This is what I got for nitrogen, 1s2, 2s2, 2p3. How many valence electrons does it have? 5 is correct. There are 2 here, and there are 3 there for a total of 5. Now, is it easier to go to 0 or gain till 8? Gain till 8, and that means it would look like this. So it started out as an atom to have 5 valence electrons, and as an ion, it lost those valence electrons, so it would have a charge, it gained those electrons to have a charge of -3. How did it do that? Started out with 7 protons and 7 electrons in the atom. It gained 3 electrons, so its charge is -3, and it can be written either way. Now silicon has a electron configuration of 1s2, 2s2, 2p6, 3s2, 3p2. How many valence electrons does it have?
4.
It has 4 valence electrons. It sits halfway between. It can either get rid of or it can gain the electrons. So what do you think its oxidation number or charge would be?
Could be either one.
Yep, +4 or -4, it doesn't matter, because it is equally as easy to get to neon or to argon. Alrighty then. Moving on. When we're talking about bonding, it's really important that you be able to figure this out. This is what we just did. Sulfur wants to be like argon. The sulfur atom is 1s2, 2s2, 2p6, 3s2, 3p4 with its 6 valence electrons. When it's an atom, it has no charge. It has 6 valence electrons. Energetically, it takes less energy to gain 2 than get rid of 6. So it does gain those 2. So the anion has the electron configuration of argon, and its charge is -2. Did you write what we did on the Elmo? Okay, so you don't have to write this. And here is sodium copycatting. It would like to be 1s2, 2s2, 2p6. In order to do that, the atom must get rid of its 1 valence electron, and it becomes a cation with a +1 charge. So this outermost electron is gone. And so now the new outermost shell has a full outer valence electron that's called a what?
Valence electron. The outermost.
Starts with an O.
Oh.
Kinda, octet.
Whatever.
Here's a memory hook that I want you to use. So on the outside of the triangle, write the group numbers. On the inside of the triangle are the oxidation numbers, or the charges. Write this in your notes. Okay, here you see the valence electrons 1, 2, and 3. You know that it's easier for them to lose their valence electron. Then this would be like silicon, either or. And then group 15 has 5 valence electrons. It wants 8, so it adds 3. 16 has 6 valence electrons. It wants 8, it adds 2. And group 18 does what? Yeah, absolutely nothing, because it has that word again. It has that octet. Okay. All right, do some writing here, and I'll catch up with you in a moment. How many people stayed up and watched all of the Super Bowl? I was way wrong on my prediction, by the way. I did not stay up and watch the whole thing. And then the blackout happened. I thought, shh. Okay, everybody has a periodic table in front of them. With your finger, outline the transition metals. Keep going so I can tell if you're right or not. Some of you are, some of you are not. Here are the transition metals. These are the inner transition metals. These are the transition metals. Remember the oxidation number of the charges of all the other metals that we were talking about with the triangle? Doesn't work for the transition metals because they don't play nicely. Some of the transition metals form multiple charges. That's called multivalent. Somebody has to tell you what the charge is. There are 4 that are transition metals. Find them on your periodic table now. That cannot form multiple charges. Did you find them? This is hugely important for you, and I promise you, if you can remember what these 4 are, you are going to be a lot happier when we start naming compounds. I made up a memory hook that really has no memory other than, I can say it fast, ASCA. ASCA. It stands for the A in silver, the Z in zinc, the C in cadmium, and the A in aluminum. Has anybody read or seen the Harry Potter movies? Where was Sirius Black taken when he was in prison? What was the name of that prison? Azkaban. Here you go. Azkaban. Azkaban. They are locked into their charge. Do you get it? Locked into their charge. If you're not a Harry Potter fan, please look at the kind of cool thing that happens on the periodic table. Are you looking? Are you looking? Get it?
Stairs.
1, 2, 3. Okay, on the lowest stair, and then these 2 are on the next highest stair, and there's the third. +1, +2, +2, +3. Get it? Which one do you like? I like the ASCA, and actually I refer to the ASCA all the time when we're doing this. Now, that's it for today.